Well, hey everyone, this is Jason at Alorium Technology, and this video is going to be kind of a long-form introduction or overview of a project that we're working on that we've kind of hit this intermediate step, and I thought it'd be kind of fun to show you guys what we're doing and how we're using one of our snowboards to interface to some Quadrature encoders and generate some data, do some analysis on it, and then connect it to an IoT platform. Now, if you remember, late last year, we released a video that talked about how you can use our Quadrature XB, whether that's on Accelerate or Snow, and be able to use that for capturing data off from our Quadrature encoder, and really showed the benefits of doing that in hardware instead of doing it just running on the microcontroller. And we're going to kind of take that to the next level to show you how you can actually apply that in a particular situation that we've set up. Now in this case, we've got 3 motors that we're going to show you generating that Quadrature data. We're going to be really channeling all of that into just one of our snowboards that's inside of a module. And in that board, we're going to be taking in all that Quadrature data and feeding it to a clustering algorithm. In this case, we use a k-means clustering algorithm, which is sort of an unsupervised clustering approach that we use just simply to create some visualization of the data. Now, in this particular case, the k-means algorithm is actually running on the AVR microcontroller, not in the hardware. That's the way it's set up today currently, but the Quadrature interfaces are based on our XBs that we'll make available for our boards, and those are all running in the FPGA hardware, and then we're passing that data into the k-means clustering and connecting it to the cloud so you can get a look at what's going on there. So again, this is just kind of a stepping stone on a project that we're working on, and we'll continue to update you and show you what we're doing, but this was a great place to stop and introduce you to this concept again, or revisit this concept in the context of an actual project that's doing some interesting stuff. And we just want to show you, again, the power of being able to take in this data in the hardware, do something interesting with it, and then send it up to the cloud and represent that in a way that's visual. And we're going to be doing that using the Ubidots platform. And so hopefully you enjoyed this. Like I said, it's a longer form video, but there's a lot of stuff to go through, and hopefully you get some interesting information out of it. And look forward to hearing your feedback on it. So thanks for watching, and I hope you enjoy. Let's dive right in. Let's take a quick look at the Ubidots dashboard itself. Now, it's pretty self-explanatory. As you can see, we've got motors 0, 1, and 2 across the top here, green, blue, and red. And if I turn the RPMs up on motor 0, you'll see this gauge jump up on the green gauge here, and you'll also see down below the graph start to move. Now, the reason it's actually bouncing around a little bit, that's intentional. We've added some jitter on the motor control side of things. We're adding jitter to it because it gives us some interesting data to graph in terms of the clustering that we're doing. So that's why you're seeing that bounce around. And you'll see the same thing here as we add, or as I add some speed to motor 1 and motor 2 and get those up and going. You'll see the graphs pop up and they'll start to run, and you'll see the same thing. You'll see it jittering around a little bit, and that's intentional. Obviously, we're using a motor control shield inside the motor control box, and it would keep a perfect RPM if we wanted it to, but we want to add that jitter in there to make the data interesting to look at. And now what you can see here is we've got the RPMs going, we've got the 3 different motors running at different speeds, and you can see this data kind of jumping around. Now, what's going on in the bottom right-hand corner of the Ubidots platform is this is representing kind of the center point or the centroids of the data clusters that you see in the graph up and to the right of that. So you can see these data points jumping around. And as I change RPMs, those kind of slide around, and we're going to talk a little bit more about what's going on here and how that's related to what's showing up on the dashboard. But first, let's transition to taking a look at a little bit higher level and the entire setup, what you're seeing on the table here and how things are hooked up and what's going on, and then we'll jump back to the demonstration. Okay, so here we are with a representation of our setup, and as I said, we've got this motor controller with really 3 knobs on there that we can use to control the speed of each one of the motors. That's fairly straightforward. Inside of that box is one of our Accelerate boards and an Adafruit motor control shield. And of course, mounted on each of the motors is a Quadrature encoder. And that Quadrature data is being taken from the encoders and fed into this other box that I just kind of labeled as a sensor hub. It's not necessarily the best actual name for it, but that's just what we'll call it for right now. So each one of the motors independently is streaming that data into the sensor hub. And just to provide a little additional information regarding the motors and Quadratures, these motors can run at a maximum speed of 5,000 RPM, and the Quadrature encoders that are on there can provide 2,048 ticks per revolution. And so that ends up being about 170,000 ticks per second that we're feeding from the Quadratures into the sensor hub. Now, coming out of that sensor hub box, we have 2 connections that are going back to the laptop. One provides Ethernet connectivity that allows us to talk to Ubidots and provide our cloud information, our dashboard information. And the other one is a serial UART connection that allows us to talk to a processing script that does some graphing and local data display that we'll talk about in just a moment. Now, this sensor hub box is actually a lot larger than it needs to be because there's not much in there. The core processing element that's in there is one of our snowboards. And so all of that data, the Quadrature data from the motors, as well as the control going out to the Ethernet connectivity, to the Ethernet connection and the UART, is all coming from the snowboard. And so if you want to get kind of a better look at the inside of that, we can kind of look at it, the actual picture with the top off. And again, here you can see our snowboard, and inside we've got some stuff to handle power. We've got a little module for the Ethernet, and then we've got our connectivity going out to the quadratures. So a lot of real estate in this box right now, but we really wanted to use this as just kind of an initial prototyping platform. So now let's take a look at what's happening on the laptop in terms of the display that we're seeing. The first thing you'll see highlighted in blue here is our Ubidots dashboard. That's of course running in the cloud, and that's representing the RPM data for each one of the motors as well as the centroids for these data clusters that are showing up in the other window. And this smaller window is a graph that is being generated by a processing sketch that's running on the laptop. So in the background, we have processing up and running, and it's running a sketch, and all it's doing is taking data from that UART transmission coming from the sensor hub and creating a graph of the data. And what it's actually showing is a ratio of RPMs from each one of the motors to the other. So we've got 3 different plots, and you can see this data kind of jumping around, but we'll talk a little bit more about what these clusters are and how it's generated and what it means and what's getting sent up to the dashboard as we look at the live view of this thing. Just wanted to provide a high-level picture of what's going on. Hope this helps. Let's dive back into the demonstration. All right, let's jump back into the demonstration. We have a slightly different view now of the setup. Instead of seeing the entire setup looking down at the table here, you can see we're just looking at the motors, and all 3 motors are running. You know, motor 1 somewhere around that 3,000 RPM, 2,000, and then just over 4 for motor 2. Now, what you can see here is we're collecting this data off the Quadrature encoders from the motors like we talked about in the setup. And right now we're only keeping a history depth of 50 points as we're doing these k-means calculation and that clustering algorithm that we're running on the data. And this window you're seeing up above the motors here, this is actually the processing sketch that is running in the background. It's harvesting the data directly locally on the laptop where we're plugging the output of our module into. So it's actually running that clustering locally on the machine. Well, it's running it on the snowboard actually, but it is then outputting the results of that to the laptop so it can be displayed in processing. The idea here is just to show the kind of data harvesting and what's going on in the processing that's being done locally on the snowboard, just so you can get an idea of what's happening. And then we're taking that data and we're actually, the only thing we're sending up to the cloud are just the centroids. And this really is being done to demonstrate that there's a bunch of processing and analytics that you could be doing at a small local level, but then really you may only want to care about specific information related to that data, and we can push that up to the cloud by just grabbing those centroids or the key pieces, which is really maybe all you'd really want to care about remotely. You don't necessarily need to transfer a whole bunch of data to a platform or somewhere in the cloud. You really only need to know about the important pieces of it. So, as we move these RPMs around, we can watch these data clusters shift and move. We are only running with a history depth of 50 data points, which isn't very many actually. It's not a lot of data, but it creates quick movement and it creates some interesting transitions to be able to watch. So as we change the RPMs here, you can very quickly watch these 50 points slide around. If we had a lot larger history data set, it would take sort of longer for that to slowly migrate and move along in those clusters. So keep in mind here what's going on. There's actually a lot taking place, and it's all just happening on the small FPGA that's sitting on the snowboard. So we're taking all of this Quadrature data coming in from the motors, bringing it into the FPGA. That's being handled by our Quadrature XBs that are running out in the FPGA fabric. The results of that are being passed into the k-means clustering algorithm, which is running on the microcontroller on the FPGA in the 8-bit micro, the AVR that we have on board there. So all that clustering and data is being done there. And then we're grabbing the centroid points and loading those up to Ubidots from the snowboard as well. And that's being done using a RESTful API interface to make that communication. And that's what you're seeing here on the platform. Obviously, in addition to that, we're sending the raw RPM data so that you can see what's going on. Now, one thing that's important to mention here is the representation you're seeing of this clustering data and these dots. What this actually represents is a ratio of RPMs from one motor to another. So we're basically seeing all the combinations. So motor 0 to 1, 0 to 2, and 2 to 1. You're seeing those three ratios. That's what's being represented here. And so that's why in a case like right now where we've got one motor turned off, you sort of got those red and green clusters are just completely pegged to the axes because of it's a measure of ratio. And with one of the motors running at 0, you're always going to have two motors that are, running at a speed relative to something not moving at all. And then as we start changing this around, you'll see that as you start turning motors off, again, the data just kind of pins itself to the axes just by virtue of the fact that we're demonstrating these ratios. And this is just a demonstration vehicle. I don't know that ratios of motors are necessarily interesting to anybody, but it's one way to show that you can do some calculation, you can harvest a bunch of data, we just kind of picked this as a arbitrary way to grab data, cluster it, sort it based on something, and then be able to push it up to the cloud. Hopefully, this at least gives you some ideas of the things that are possible. Even with a tiny little FPGA like Max 10 and a small board like the Snowboard, we really can do a lot of things here. And this really, honestly, isn't even taxing the FPGA whatsoever. And we could add basically as many of these Quadrature inputs as we wanted to, as many as we had pins for, and it wouldn't slow things down at all. And we could easily process all of that data coming in parallel. So once we get the K-means clustering moved into the FPGA, we'll update this demo again and kind of show you some of the things that are different. But for now, I just wanted to at least give you a taste of what's coming with this video and demonstration that combines nicely the Quadrature XB along with something of a kind of an unsupervised machine learning algorithm running on that same board, and then interfacing very nicely with an IoT platform that provides information about what it's doing and what's going on. Hopefully this was interesting for you. Please let us know if you have any questions or anything specific you'd like to see or any comments you have. We'd love to hear from you. Thanks again for watching.